Okay, relation between heat of reaction at constant pressure QP and heat of reaction at constant volume dQB. We know that from question we have already discussed question B I and B third. dQP equal to delta H and QB equal to delta E. By the definition of enthalpy at constant pressure, delta H equal to delta E plus P delta V. So we can change V delta V B2 minus B1. So delta H equal to delta E PB2 plus minus PB1. For guide ideal gas equation PB equal to nRT. So we can write delta H equal to delta E N2 RT minus N1 RT. Delta H equal to delta E plus RT common N2 minus N1. So delta H equal to delta E plus delta N RT, where delta N equal to N2 minus N1. N1 is the number of mole of reactant and N2 is the number of mole of product. So from equation first and fourth, equation first dQP equal to delta H, delta H equal to delta E plus delta N RT. So dQP equal to dQB plus delta N RT. N1 is the number of mole of reactant and N2 is the number of mole of product using relation first in fourth. We have equation first dQP equal to delta H and fourth equation delta H equal to delta E plus delta nRT. So we can write dQP equal to delta H delta E plus delta nRT. Again, from equation second, we have written equation second delta QB equal to delta E. So that dQP equal to dQB plus delta nRT. Equation fourth can be studied under different case when the reaction is carried out in closed vessel, keeping the volume constant. Equation third changes to delta H equal to delta E. When the reactants or products involves only solid, liquid, or solution, but not gas, then the change in volume is almost negligible. Delta H equal to delta E. The reaction is carried out in closed vessel, keeping the volume constant. Delta H equal to delta E. Reactants or products involves only solid, liquid, or solution, but not gas. Then change in volume is almost negligible. Delta H equal to delta E. When gases, reactants, and products are involved, but the number of mole does not change during the transformation, delta N equal to 0, and the relation QP equal to QB plus delta nRT changes into QP equal to QB. Delta is equal to delta E. This is the true in case of the flame chemical transformation. When the hydrogen dioxide chlorine gives hydrochloric acid, hydrogen dioxide iodine, hydrogen iodide. Some facts on enthalpy: total heat content, enthalpy equal to internal energy plus PV work, or H equal to E plus PV. Absolute value of enthalpy cannot be measured, and fortunately, it is not necessary to. But change in the enthalpy of system can be measured. Enthalpy is a function of temperature, pressure, and volume, that is H equal to F PTV only. Its value does not change depend upon the previous story, but only depends upon its initial condition and final condition. If a system having the enthalpy H1, internal energy 1, and volume V1 at constant and volume V2, then the change in enthalpy is measured as H1 equal to U1 plus P1, similarly as 2 P2 plus P2, PV2. So H1 minus H2 equal to delta S, delta E plus PdV. When a system returns to its original state after a number of change in the cyclic process, delta is equal to 0 or dH equal to 0, delta is exact differential. Euler's theorem of exactness can be applied to show dava square S, dava T, dava B equal to dava square S, dava B, dava T. Enthalpy is a extensive property. Its value depends upon the quantity of matter present. A fixed quantity of chemical substance have fixed value enthalpy of under conditions, under given set of conditions. The values of enthalpy are different for different substance. Okay, sorry, listen again. Enthalpy is an extensive property. Its value depends on the quantity of matter present. A fixed quantity of chemical substance has a definite value of enthalpy under a given set of conditions. The values of enthalpy varies from one substance to another.